Hello students, this is Harish Konda. Welcome to my channel, the Chemistry Classroom. Today we are going to discuss about nucleophilic substitutions. And in the previous videos we discussed about free radical substitutions and electrophilic substitutions. In the description the link is given. Please follow that videos. So now we are discussing about the nucleophilic substitutions. The nucleophile is eliminated and the nucleophile is substituted. That's why the reactions are called nucleophilic substitution reactions. Already we discussed about the substitution reactions. Generally, from the compound, one atom or a group is eliminated and the group or atom is substituted. So the reactions are called substituted. Here, in the nucleophilic form, in the nucleophile form, the atom or group is eliminated. In the nucleophile form only, that atom or group is substituted. So that's why the reactions are called nucleophilic substitution reactions. So one general example we'll take. For example, the A and B is a compound. The AB compound, the A and B are involved in covalent bond. The two are having the electronegativity difference. The two are having the electronegativity difference. So when they are reacted with Y minus. So what we are reacting it is Y minus is reacted. So automatically what happened here you see. So in the A and B, in the bond, the covalent bond. So here the A and B is having the electronegativity difference. So the electrons are moved towards the B. The B is getting negative charge. At the same time the A is getting positive charge. Why? Because the electrons are moved towards the B. So automatically what happened here you see, the B minus is eliminated and the Y minus is attached. So automatically the B minus is eliminated and Y is attached. So here one nucleophile is eliminated, one nucleophile is substituted. So one nucleophile as an atom or a group it is eliminated. So one nucleophile as an atom or a group it is added or it is substituted. So automatically you are getting this compound. So in this reaction, what is involved? The nucleophiles are substituted by the nucleophiles. Substituted. So that's why the reactions are called nucleophilic substitution reactions. Generally, these reactions are having the mechanism. That mechanism completely we discuss. So here in the nucleophilic substitution, lot of mechanism is involved. That mechanism we will discuss. So in the nucleophilic substitution reactions, the mechanism, we have two type of mechanisms. The two mechanisms are involved. So which compounds are undergoing the mechanisms? Now we discuss one by one. So here for example, we are taking the compound A and B. The two are having the electronegativity difference. They are reacted with Y minus. So automatically the electrons are moved towards the B. Why? Because the B is having high electronegativity. The electrons are moved towards the B and B is eliminated as a nucleophile and Y is substituted. So these reactions are called nucleophilic substitution reactions, already we discussed. So in this reaction, so very first mechanism we discussed. That mechanism is called SN1 reactions. SN1 reactions or SN1 mechanism. So what is SN1 mechanism? You see. In SN1 mechanism, the nucleophilic substitution. What is SN? Nucleophilic substitution monomolecular. What it is? Nucleophilic substitution monomolecular. Why? Because in the rate of reaction, only one molecule, the main compound is involved in the mechanism. That's why the reactions are called, the mechanism is called SN1 mechanism. I repeat, so monomolecular, nucleophilic substitution reactions monomolecular. In this, so mainly the rate of reaction determines only one compound. That's why it is called monomolecular nucleophilic substitution reactions. In this mechanism, the two steps are involved. So what is your first step? Step 1. So what is your first step? You see, the A and B have the compound. So here the fusion is occurred. That means heterolytic cleavage is occurred. So the electrons are moved towards the B and B is getting negative and the A is getting positive. So what happened here? The two ions are formed, A plus and B minus. So here in the step 1, the A and B involved in heterolytic cleavage. The electrons are moved towards the B. The B is getting negative charge and the A is getting positive charge. Now what happened here? A plus is formed. Now it is involved in step 2. So what is the step here? The A plus is formed. Now the A plus is reacted with Y minus. So automatically the compound is formed. So in this mechanism, SN1 mechanism, here we have two steps. Step 1, in the first compound, it is involved in heterolytic cleavage. The electrons are moved towards the B is getting negative and the A is getting positive. This positive ion is reacted with the nucleophile. Now it is nucleophile is reacted, so automatically what happened? AY is formed. In these two steps, so what is the rate of reaction depends here, you see. So very first A and B get cleavaged. When A plus is formed, then only the step 2 is possible. The step 2 is not involved in the rate of reaction, only step 1 is involved in the rate of reaction. In the rate of reaction, how fastly the bond is cleavated, so that is determines the rate of reaction. So if the bond is cleavated very fastly, the reaction completed very fastly. If the bond is cleavated very slowly, so automatically the reaction is getting very slow. Why? Because in the rate of reaction, how fastly the electrons are moved towards the B and A plus and B minus is formed, that is dependent. So why? Because in the step 1, the bond is very fastly cleavated, so automatically A plus is formed, automatically A plus is reacted with Y minus and compound is formed. So in the rate of reaction, only one compound, the AB compound only involved in the rate of reaction. That means, so this is nucleophilic substitution. Ultimately we are getting the substitution. The B is eliminated and the Y is substituted. So it is nucleophilic substitution only. But what happened here? So in the rate of reaction, only the AB compound is involved. AB compound is involved. How fastly it is cleavated, that is only determines the rate of reaction. So the first step is the rate of reaction. So in the first step only AB compound is involved. That's why it is called SN1 reactions. Nucleophilic substitution monomolecular. Why? Because only one molecule is involved. So that's why it is called SN1 mechanism. So we take one example. Here it is 2-methyl 2-chloropropane. The compound is 2-methyl 2-chloropropane. This compound involved in nucleophilic substitution reaction. So what you are forming? 2-methyl 2-hydroxypropane or 2-propanol. So this compound is formed. In this compound, so in this reaction, what is the mechanism is involved? It is SN1 mechanism is involved. So how it is involved, you see. So here the bond is cleavated. Why? Because the carbon and chlorine is having the electronegativity difference. The electrons are moved towards the chlorine. The chlorine is getting negative charge and the carbon is getting positive charge. So in the water, the electrons are moved towards the OH side. So the hydrogen is getting positive and the OH is getting negative charge. So here the carbon and chlorine is getting heterolytically cleavated. The electrons are moved towards the chlorine is getting negative charge and the carbon is getting positive charge. So in the water we have formed one nucleophile, it is OH minus. So the Cl minus is eliminated with H plus as HCl, then OH minus is attached with the carbon, so automatically the compound you are forming. In this reaction, only the chloropropane, 2-methyl 2-chloropropane is involved in the rate of reaction. So that's why it is called SN1 mechanism. Why? Because in the very first step, so what happened here? The carbon and chlorine getting cleavated, the electrons are moved towards the chlorine, the carbon is getting positive charge and the chlorine is getting negative charge. So in the initial step, step 1, so what happened here? The carbon is getting positive charge and the chlorine is getting negative charge. Why? Because the carbon is the tertiary carbon. What you form? So the tertiary carbocation, now it is involved with OH minus ion to form the compound. So what happened here? The tertiary carbocation, so it is involved. Now it is reacted with OH minus. So automatically the compound you are getting. So in this reaction, you observe the tertiary carbon which is attached to the chlorine, the electrons are moved towards the chlorine, the chlorine is cleavated heterodytically, the chlorine is eliminated as a nucleophile. So one carbocation is formed. So what is the carbocation? Is tertiary carbocation. Why? Because the carbon is attached with 3 carbons. So which is attached with the 3 carbons, that carbon is called tertiary carbon. The tertiary carbon is having the positive charge. So here what happened? The tertiary carbocation is formed due to hyperconjugation, so etc etc. The carbon is very stable, so the carbocation is very stable. So that's why the first step is involved to form the carbocation. After that step only the OH minus is reacted and the compound is formed. So in this reaction the rate of reaction is dependent on the first step. So the carbocation, how speedily the carbocation is formed, that carbocation is reacted with OH minus, so automatically the compound you are getting. So that's why this mechanism is called SN1 mechanism. In the first step the tertiary carbocation is formed. In the second step, so the tertiary carbocation reacts with nucleophile, so automatically the compound is formed. That's why the mechanism is SN1 mechanism for this reaction. So the tertiary chloride is reacted with the OH minus ion and tertiary alcohol is formed. This reaction undergoes in SN1 mechanism. Now we see the second mechanism, SN2 mechanism, nucleophilic substitution bimolecular. What is that? Nucleophilic substitution bimolecular. In this reactions, the rate of reaction depends on 2. The one is compound and the second is nucleophile. The 2 are involved in the rate of reaction. That's why it is called bimolecular mechanism, bimolecular nucleophilic substitution. Why? Because in the rate of reaction only one step is involved, in that the A and B is getting cleavage and Y and A is getting bonded. So how you see, in the rate of reaction only these 2 are involved, the 2 compounds are involved. One is compound is involved and the second is nucleophile is involved. The 2 are involved, so it is called bimolecular nucleophilic substitution bimolecular. Here you see, so the Y minus, the nucleophile is when it is attached with the, when it is attacked with the AB. So what happened here? The A and B is getting cleavated and Y and A is getting bonded. So here we are involved the 2 steps. So A and B is getting cleavated and Y and A is getting bonded. So here in this reaction, so we are getting one intermediate. What it is called? Intermediate. The intermediate is unstable. Why? Because here we have the, from the intermediate we have the 2 possibilities. If the A and B bond is not cleavated and A and Y bond is not formed, so what you are getting? The reverse reaction you are getting, the AB compound and Y minus only we are getting. Why? Because here the bond is not cleavated, so the Y and A is not bonded, so automatically the reactants only again it is formed. But when the A and B bond completely cleavated and Y and A if it is bonded, so automatically you are getting A and Y and B minus is formed. So in this reaction you see simultaneously the bond is broken, simultaneously the bond is formed, so automatically you are getting the product. So in this reaction the rate of reaction depends on the 2 compounds. The 2 are involved. So it is bimolecular. So nucleophilic substitution bimolecular. So in the rate of reaction one intermediate you are forming. In the intermediate it is very unstable. That's why we are showing in the bracket. Why? Because it is unstable. So from that intermediate you can form the reactants. From the intermediate you can form the products. If A and B completely cleavated and Y and A completely bond formed, so automatically you are getting the products. If the bond is not cleavated and the bond is not formed, you are getting the reactants again. So that's why the reaction mechanism is called SN2 mechanism. Here what happened, you see, the Y minus attacked from the left side and from the right side the B is eliminated. And from the back side the Y is attacking, from the front side the B is eliminated. That's why this attack is called backside attack. Backside attack. So here we are getting 2 mechanisms. One is SN1 mechanism, the second is SN2 mechanism. So the A and B is the compound. So the Y minus is the nucleophile. When the nucleophile is attacked AB, the A and B is getting cleavated, the Y and A is getting bonded, so you are getting the products. The product is reversed. The product is reversed. That's why this attack is called backside attack. In the mechanism, from the backside Y is attacking, from the front side the B is eliminated. So that's why the reverse, the universally reversed compound you are getting. So the complete mechanism, it is called SN2 mechanism. We take the live example. Okay. So now we take another example, the methyl chloride. The methyl chloride is reacting with OH minus. So what happened here? The carbon and chlorine is having the electronegativity difference. The electrons are moved towards the chlorine. The chlorine is getting negative charge and the carbon is getting positive charge. So automatically the OH minus is attached, and what compound you are forming? The alcohol compound you are forming. The hydrogen in the water, the hydrogen you have H plus ions. The H plus ions with Cl minus ion, what you are eliminated? The HCl you are eliminated. In this reaction, Cl minus is eliminated and OH minus is substituted. So it is the example for nucleophilic substitution reactions. So it is SN2 mechanism. So what is the SN2 mechanism? In the reaction, rate of the reaction, the two are involved. So that is bimolecular reaction. So the two are reacted. Why? Because the carbon is having the positive charge, is less stable only. That is primary carbocation. What you form? The primary carbocation you are formed. So in this reaction, what happened here? The carbon and chlorine getting cleavated. At the same time, the O and OH minus and carbon is getting bonded. So here the electrons are moved towards the chlorine and the carbon is OH is attached in the carbon. So what you are forming, one intermediate you are forming. Here the carbon, in this the carbon and chlorine bond is cleavated. At the same time carbon and OH bond is formed. So when the bond completely, when intermediate you are forming, when the carbon and chlorine bond completely cleavated and the OH and carbon bond is formed, so what you are getting? The alcohol compound you are getting. So here the backside attack, but it is called backside attack. So the carbon is having only hydrogens. It is a primary carbon. The primary carbocation is forming. It is very less stable. So that's why it is involving SN2 mechanism. Simultaneously the carbon and chlorine is getting cleavated. So OH minus and carbon is getting attached. So here even intermediate you are forming. In the intermediate the carbon and chlorine is getting cleavated. The chlorine is eliminating. At the same time OH minus is attaching to the carbon. So what compound you are formed? The alcohol compound you are formed. So very first you see, observe here the chloromethane and alcohol, methyl alcohol. When you observe these two, the chlorine from the front side, the chlorine is eliminated. From the back side, the OH is attached and the methyl alcohol you are formed. The back side attack is completed and the reversible compound you are formed. The reversible compound you are formed. So that is the mechanism, that is SN2 mechanism. In the rate of reaction, the nucleophile and the compound, the two are involved. So one intermediate you form. From the intermediate, the bond is completely cleavated. When bond is completely formed, so automatically you are getting the compound. So that's why that reaction is having the mechanism SN2 mechanism. So like that, the nucleophilic substitution is having two mechanisms. The one is SN1 mechanism and SN2 mechanism. So generally we have to observe the SN1 and SN2 mechanism, where it is occurred, where the compound is involved in SN1, where the compound is involved in SN2. So we have to discuss, that is depends upon the carbocation stability. That stability later we discuss. Okay, thank you. So students, please don't forget to like, share, comment and subscribe. Thank you.